Hello everyone, my name is Andy Chin Yu, and today I will presenting my task for the course Computational Thinking in Mathematics. The title of my presentation is Solving a Non-Routine Mathematical Problem Using Computational Thinking. In this presentation, I will explain what non-routine problems are and how computational thinking help us solve them in a structured and effective way. First, let us understand what a non-routine mathematical problem is. A non-routine problem refers to a situation where the problem cannot be solved directly using standard formulas or memorized steps. Unlike routine problems, where students can simply apply a non-method, non-routine problems require deeper thinking. Students need to interpret the situation, explore different strategies, and make logical decisions before arriving at a solution. This makes non-routine problem solving very important in 21st century learning because it develops higher order thinking skills such as analysis, evaluation, and critical thinking. There are several key characteristics of non-routine problems. Firstly, there is no direct formula or fixed procedure, so students must think to and decide which strategy to use. Secondly, these problems involve higher order thinking skills, not just basic calculation. Thirdly, they often have multiple possible solutions, meaning different approaches can lead to valid answers. In addition, non-routine problems are usually connected to real-world situations, making them more meaningfully and relevant. By integrating computational thinking, students can approach these problems in a more structured and organized way, which improve their problem-solving ability. Now, I will introduce the problem that I selected, which is based on real-world situation, known as the traveling salesman problem, or called it TSP. This problem is commonly used in logistics and optimization. In this case, a delivery driver needs to visit four locations, which are Mua, Batu Pahat, Johor Bahru, and Mersing. The objective is to find the shortest route that visits all locations exactly once and return to the starting point. This problem is considered non-routine because there is no direct formula to find the answer. Instead, we need to explore multiple possible routes and compare them. The problem also requires optimization, which means finding the best solution among many options, which is compare the routes. This type of problem is highly relevant in real life, especially in delivery services such as Grab, Shopee, and logistics companies, where efficiency can save both time and cost. To solve this problem, I applied computational thinking, which is a structured approach to problem solving. Computational thinking consists of several steps, including decomposition, pattern recognition, abstraction, algorithm, evaluation, and logical reasoning. Each of these steps plays an important role in helping us break down the problem and solve it systematically. Instead of guessing randomly, computational thinking allows us to approach the problem in a logical and organized answer. By following these steps, we can transform a complex problem into a series of manageable tasks, making it easier to understand and solve it. Okay, let us go through to the first step, which is decomposition, which means breaking the problem into smaller and more manageable parts. In this problem, I started by listing all locations involved, then identifying the distance between each location. After that, I generated all possible routes and calculated the total distance for each route. By breaking the problem into these smaller steps, it becomes much easier to understand and solve instead of dealing with the complexity all at once. The second step is pattern recognition. In this step, I analyze the routes to identify useful patterns such as the shortest connections between locations, repeating routes, and symmetry in the route arrangements. For example, the route between Muar and Batu Pahat appears to be one of the shortest connections, making it an important part of efficient routes. Recognizing these patterns helps reduce unnecessary calculations and allows us to focus on more promising solutions. Next is abstraction, which involves focusing only on important information while ignoring irrelevant details. In this case, I focus only on distance and route order because these are the key factors needed to solve the problem. At the same time, I ignore factors such as traffic conditions, weather, and personal preference as they are not relevant to this mathematical model. Abstraction helps simplify the problem and allows us to concentrate on the essential elements, making the solution process clearer and more effective. The fourth step is algorithm, where I develop a clear step-by-step procedure to solve the problem. First, I started at one location. Then, I listed all possible routes that visit every location once. After that, I calculated the total distance for each route. Next, I compared all the results. And finally, I selected the route with the shortest distance. This algorithm provides a systematic way to solve the problem and ensures that the solution is not based on random guessing. It also makes the process repeatable and easy to understand. For this part, after applying the algorithm, I calculated several possible routes and their total distances. For example, one route gives a total distance of 530 kilometers, while other routes result in 540 kilometers or even 710 kilometers. By comparing all the routes, I found that the shortest distance is 530 kilometers. Interestingly, there are two different routes that produce this same shortest distance. This shows that in non-routing problems, there can be more than one optimal solution. This step is important because it demonstrates how systematic calculation and comparison lead to the best possible answer. In this step, I applied logical reasoning and evaluation to verify the solution. All possible routes were evaluated carefully, and the shortest one was selected. I also ensured that each location is visited only once and that the road returns to the starting point. This step is important because it ensures that the solution is valid, accurate, and efficient. Logical reasoning helps to justify the answer, not just calculate it. From this task, I gained several important insights that changed the way I see mathematical problem solving. Firstly, I realized that the shortest path is not always obvious at the beginning. In many cases, what seems like the shortest route intuitively may not actually be the most efficient one. This shows that in non-routine problems, we cannot rely on assumption alone. Instead, we must test multiple possibilities systematically before making a decision. This process strengthens our analytical thinking and encourages us to be more careful and precise. Secondly, I learned that one problem can have multiple optimal solutions. In this case, there are two different routes that result in the same shortest distance. This highlights that mathematics is not always about finding a single correct answer, but rather about identifying all possible best solutions. It also shows that flexibility in thinking is very important when solving complex problems. Another important insight is that mathematics play a significant role in decision making, not just calculation. Through this task, I was able to see how mathematical reasoning can be applied in real world situations, such as planning delivery road efficiently. This means that mathematics helps us make better decisions based on logic and evidence rather than guessing. Finally, this task also helped me understand the importance of having a structured approach. Without computational thinking, it would be very difficult to organize all the routes and compare them effectively. Therefore, I can conclude that combining mathematical thinking with computational thinking allows us to solve problems more confidently and accurately. Computational thinking is highly effective in solving non-routine mathematical problems because it provides a clear and systematic framework. Instead of approaching problems randomly, it guides us step by step, starting from understanding the problem until evaluating the final solution. The structured approach makes complex problems more manageable and less overwhelming. One of the main strengths of computational thinking is that it helps to break down complex problems into smaller parts through decomposition. This allows us to focus on one aspect at a time, which improves clarity and reduces confusion. At the same time, pattern recognition helps us identify useful relationships and avoid repeating unnecessary work, making the process more efficient. In addition, computational thinking enhances higher order thinking skills. It encourages students to analyze information, evaluate different options, and make logical decisions. This is very important in modern education because students are expected not only to solve problems, but also to explain and justify their solutions clearly. Furthermore, computational thinking develops critical and logical reasoning. In this task, I did not simply calculate distances, but I also had to justify why a certain route is the best. This shows that problem solving is not just about getting the best answer, but also about understanding the reasoning behind it. Another important point is that computational thinking promotes organized thinking. By following clear steps, such as algorithm and evaluation, we can avoid random guessing and ensure that our solution is accurate and reliable. Overall, computational thinking is an essential skill because it not only improves mathematical problem solving but also prepares students to handle complex real world problems in a logical and systematic way. This approach can be applied in many real world situations, especially in logistics and delivery systems. It helps companies optimize routes, save time, and reduce costs. However, there are some limitations. Solving this problem manually can be time consuming, especially when the number of locations increases. It also becomes more complex for large scale problems. To overcome these limitations, technologies such as programming and artificial intelligence can be used. These tools can automate calculations, improve speed, and increase accuracy. This also supports meaningful learning by connecting mathematical concepts with real-life applications. These are the references that I use in completing this task, including academic sources related to the problem solving, computational thinking, and optimization problems. That's all from me. Thank you for your attention. I hope this presentation has helped you understand how computational thinking can be used to solve non-routine mathematical problems.